Hi, everyone. Thank you for joining us for this session, Build Intelligent Apps with Serverless Containers on Azure Container Apps. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping links and checking for questions for our presenter to answer live. The session is recorded and will be available to view on demand in 24 to 48 hours. With that, I'll turn it over to our presenter. Jonah, thanks for joining us.
Hi, Anna. Thank you so much for having me today on our first episode of the Intelligent Serverless Intelligent Apps series at Microsoft Learn and Reactor. So today, I am live today. I just got off work. I'm delivering this session live from Sweden. And today, it is the first episode of the series, and I will be sharing about building and developing serverless containers with Azure Container Apps with focus with Azure Developer CLI. And before I start, there's actually great episodes coming up. This is just the first one. So there are series coming up tomorrow by other speakers. So feel free to check it out using this QR code. And I speak a lot of serverless in most of my talks and conversations and speaking at conferences. And one of the things that I speak about is actually Azure Functions for the past few years. But today it's different. It is my first time I'm going to share about serverless in containers. And when I think about serverless, I think about cloud that you can see here. And I also think about the airport queue problem because serverless actually solves a lot of queue or workflow related problems. So let's just say on the traditional infrastructure or systems that we have, sometimes it's so monolithic that we have to wait our events or things that we need to do in our applications need to work to wait on each other. And that is the same as the airport queue problem, and it can be the same on our applications when events need to wait on each other. And what if we have applications that are too complex and they get out of control and we don't know how to control them, just like the traffic or the queue of people that we see sometimes in big cities? And what if our applications today that we use a lot on our laptops and our desktops and even our mobile phones and even our IoT devices have to wait for these systems because they keep on loading and they have to wait on each other. So this is when I believe that serverless uh, AI solutions that we have today, like the Azure OpenAI and ChatGPT, the Copilot, and all the amazing trends happening right now in this technology era, where we got a lot of options to build intelligent apps with AI, and also with the combination of cloud native technology that we have today. I believe that as a developer, it will help me increase my productivity and collaborate better, learn new things with different technology stack. And it will also allow me to build intelligent apps that will solve a lot of use cases and problems. So my agenda today, hopefully in the next 45 to 60 minutes, that's the time frame that I have, I can be inclusive by giving you an introduction about what is serverless, cloud native, what are containers on cloud, what it means as top level perspective, Azure Container Apps as a technology in Azure, and also another technology stack which I'm very passionate to share about lately, which is the Azure Developer CLI, or also known as ACD. And hopefully, for about 15-20 minutes, I will be able to share a mini demo, a small demo, locally in my machine where I deploy an Azure Container Apps with Dapper along or using the developer CLI on Visual Studio Code. And of course, some learning resources to keep you going and keep learning even after this session and the upcoming series coming up. So I know that I was introduced on the speaker bio on the event, but I want to give you a quick introduction about who I am. This is my first time to speak in a reactor event in a while, but I'm Jonah Anderson. I'm based in Sweden. I am working as day job as a senior Azure consultant at Solidify. Outside work, when I'm not working and coding and working with Azure, I'm very, very active in the community as a community leader of Azure User Group Sweden, sharing about Azure events. I work a lot with cloud development and infrastructure management with Azure and some DevOps, and active in advocating diversity and inclusion in making tech an inclusive place for everyone. But to make the long story short, I am the person that gets on stage to inspire you in getting started. So, serverless and cloud native, what it is. So, serverless computing, when you hear about it or when you research about it, one of the things that you will kind of like read as a cliche is that it's not really serverless because it's wrong. I mean, it's not really serverless because there are actually serverless behind. How can it be without servers, right? Especially if you're a developer, you're thinking logically. But basically, in technical term, serverless computing is like you're having your applications or execution model on the cloud without worrying about the underlying infrastructure or back-end infrastructures behind it. So if we think about Microsoft Azure as a cloud provider, it provides serverless compute services in a form of platform as a service like Azure Functions or Azure Container Apps to allow us to we have programming languages that we know without thinking about what's behind it, the infrastructure, the VMs and clusters behind it. The cloud is taking care of that. We just need to take care of the event-driven solutions or microservices that we need to build with serverless computing. And usually, when you think about serverless computing, it's mistaken or can be considered FAS, like function as a service. But it's actually beyond that because it's not just functions that you can build serverless with. You can build containers with serverless technologies or computing. There is also databases, storage, and even build microservices with cloud native solutions like Kubernetes, Docker, and other technologies that are available today. So, just a big perspective of the serverless technologies that are currently in Azure. So there is Azure Functions that probably most of you have heard a lot when we speak about serverless. In other cloud computing provider, there is also AWS Lambda, GCP functions, I believe. But my focus today, since we're talking about Microsoft technology, is like serverless on Azure Functions, for example. And Azure Functions allows you to build event-driven functions without thinking about the infrastructure behind it. At the same time, you focus on developer productivity and business logic. And aside from the Azure function itself, it has an extension called durable functions that I speak a lot because I love that it allows us, build functions at least to serverless, like stateful workflow that you don't need to worry about managing the state. So it helps us solve some complex problems with event-driven types of use cases. And for databases, there's the serverless options for Azure SQL Server, Cosmos DB for NoSQL type of databases, Azure Logic apps. So if you're someone that are not so familiar into coding, the code-based type of building workflows, don't worry because it's also inclusive. There's Azure Logic apps that is also very powerful in terms of integrating cloud solutions, cloud services, and on-prem services with your tomorrow. Focus on that. Azure Container Apps as well. I will be introducing you with that, but all of the series will be all about cloud native serverless with ACA. So, what is really cloud native? So, I did write something about this in my book, Learning Microsoft Azure. And then when I did research about it, it was very interesting because as a developer, it made me wonder what's the difference between cloud computing and cloud native, and me already building applications with .NET with Azure to Azure on the cloud. And then I discovered this quote from CNCF. This is the Cloud Native Computing Foundation. So if you search for cloud native, they always show up, and they have this exact definition of cloud native technologies. So, cloud native technologies are actually meant for us to build modern and dynamic environments for both public and hybrid clouds. And examples of this, like containers, microservices, allows us to also make APIs that are declarative. And also, it solves a lot of problems like being able to loosely couple some coupled system, and they should be all these good things when it comes to thinking about the well architected framework for Azure, for example, that it should be easy to manage, it is flexible, easy to observe or monitor, and it's adaptable and robust and resilient when you're trying to maintain it, and you want to make changes frequently because of the business requirements and the changes that needs to happen, of course, in a real case scenario. And of course, when you make changes, it should have the minimal impact, especially in the production workload. And another feature of cloud native is also automation, which reminds me actually of infrastructure as a code, like using Bicep and like a Bicep on if you're using Azure as well, and Terraform for multi-cloud related scenarios and other automation tools. So when you think about cloud native, there are actually several pillars on Microsoft Azure, like even probably in other cloud platforms. So I'm so focused with Azure because that's what I work every day. But the cloud native pillars, how can you say or how can you tell if a system are like considered cloud native? So there are pillars that are actually a common identifiers. How can we tell? So first one is the cloud infrastructure. So let's just say in Azure, we got the most common one or deployment model used for cloud native is the platform as a service. Like for example, the Azure Container Apps. They are like considered platform as a service. You don't think about the underlying infrastructure behind it. So PaaS is common. Modern design. The modern design part here, it's a lot of things to learn. It actually follows the 12 factor application framework, which you will find out soon if you want to learn more about it. And then there's also the well architected framework for Azure, which follows this very robust pillars in terms of reliability, operational, cost management, and all those great things when you're modernizing, migrating, and building applications to the cloud or Azure. And another thing that is another pillar of cloud native is microservices. So they are ideal for microservices as distributed applications, loosely coupled those things that we need. And it actually follows the processes part of those 12-factor application framework. And then containers. So it uses containers, and it also have this pillar of backing services, like this other services behind the scenes or backend services can be integrated as part of its normal process or workflow. So I did mention the 12-factor app. If you want to learn more about the cloud native behind the scenes and following this best practice in building one, if you search on Copilot or in Google, I forgot to add the QR code, but if you search about this, you will be able to read more about this 12 factors. So if you see here, the number one is code base. Dependencies, it has a definition about best practices in terms of configuration, processes, porting, concurrency, Devon, prod parity, logs, and administrative processes. So check it out if you want to learn more about the best practices in terms of building cloud native, the 12-factor app. It's very interesting. I started reading the first one yesterday to learn more the details. So moving forward, traditional versus cloud native. So I did share about the airport queue problem, and I can compare it to some kind of traditional monolithic architecture where you have a client app. Maybe it's just like no concurrency or no event driven application or architecture implemented to it. And it's monolithic and it can be slow. But if we were to compare it to illustration 2 that we have here on the screen, it allows us actually to build a very intelligent and robust kind of microservices where you have your mobile app, you have your web app that can be accessed on the web anywhere. You have your SBA web app. It can be like responsive. It can be accessed on any kind of device. And then you have your backend services on containers. See, in this one, you see Docker host, and each of the service or functionality that you have for the web app, you can call it, has its microservice for ordering management, marketing, basket like order, like cart management, location, and it uses its distributed type of functionality for each of its purpose. And it also uses an event bus for pub sub type of event. So I do see here that it does solve the problems of concurrency, as well as making or solving the problems for users to not wait on the process and get on this loading thing. Because today, I mean, I'm a consumer myself. If I go to a web shop, I don't want to wait more than a minute. And my time is precious, and it really is a good service when you get a mobile app service or an app web app where you can get response right away. And I believe that all of us that are building systems today, even modernizing one today, we want our applications to be better, and we continue to work, we as developers, to improve it all the time. So it's interesting with cloud native, at least in my perspective, that who likes to build. So what are the typical ideal use cases for cloud native, aside from building new applications with with containers, with different technology stack. So one use case that's very common. I also speak about cloud migration a lot because of my experience. Is migrating existing applications or legacy applications to the cloud. And usually, when you migrate to the cloud, there are two ways. You can just you migrate because you need to, because you're trying to solve a major problem, or you also can modernize or combine both, actually. Modernize by implementing cloud native solutions, build it that way. And sometimes you would need to re architect and rebuild your existing infrastructure or architecture to achieve this. And also choose the right deployment model. So if you see from the left here, on the existing app on-prem, you have to choose if you're going to do the lift and shift, or you're going to choose the PaaS and containers, or completely go microservices or cloud native, moving to the right side of this illustration. So serverless, in my perspective, and I believe maybe you also who loves working with serverless and cloud native would definitely believe and agree with me that they are a perfect match, especially if you're working with that on an Azure. And Azure Container Apps, along with other serverless services on Azure, would be also ideal for that perspective. So, what are Azure Container Apps? So, Scott Guthrie, the executive vice president at Microsoft, he had this talk on Build, I believe it last year, or in the previous Build. And he did describe Azure Container Apps is like a serverless, container-based hosting service that allows you also to focus on your app development without worrying about the underlying infrastructure. So I speak about Azure functions a lot in the serverless perspective on in terms of functions. So basically, it's almost the same purpose, but you're focusing on building containers, and containers in application development has its advantages compared to VMs in virtual machines, in building containers, because of the advantage of maybe you're not tied or not locked into a specific technology. You can have different technology or programming languages in each container and build this flexibility of of services in your architecture. And of course, it is also event driven. By the way, I'm going to take the question at the end just to inform everyone. So just keep coming, your question coming in, and I'll try to answer them at the end, of course. So, what can you build with Azure Container Apps? So, I mentioned microservices, which is a typical use case also for cloud native. So if you have that kind of architecture or use case, it is ideal. And then if it's complex, you need them to talk to each other. You can use integrate it as well with Docker or AKS for orchestration. And if you have like a use case for like endpoints, public endpoints for APIs, if you want them to connect or integrate them between each other, and then web applications that you would need to have in container apps, event-driven processing type of scenarios, like you have to use like Azure Service Bus, queue, and topics, those kind of scenarios. And also background processing that you need to do, for example, with your integration between your apps and databases. And then what's special and good about Azure Container Apps is the auto scale feature. So there are ways that you can auto scale. So as you can see in this image, this is an image that I borrowed from Microsoft Learn. Uh, and it allows you to, for example, when you're using microservices, you can scale it using CADA technology or feature as well. And you can also scale using HTTP requests, and also the messages that you have in queue, and all those things that you can control with some auto scale and monitoring features. So, what are the benefits of Azure Container Apps? So, all the common benefits for serverless, like pay per use, the scaling part, which is just shared as well, and you can run your containers from either within Azure, the Azure Container Registry, which is available also, but you can also run it from any registry like Docker, private, or public types of that. And integration with other services, both inside Azure and also outside, like open source one. And it also support traffic splitting in terms of blue-green deployments and internal ingress using DNA-based service discovery feature. And I know there are more features coming up. Probably some of them I missed presenting here, but there's more, and these are just like the top ones that are good. And of course, you can use the CLI for this, so you can manage it anywhere. You can do it on Portal, CLI, and I'm also now today in my demo, I will show how it looks on Azure Developer CLI. So example use case that you see here. So you have an usually a container app. It is actually, it has a like a container app environment where you put all your container app itself. It's like a box or virtual container where you put all your containers in. And here is an example of a use case where it has an ACA environment and has a container app for both the ingestion and workflow service. And the workflow service has this different other container apps integrated with it. One that handles or that communicates with Azure Cosmos DB for MongoDB. There's the standard one, Cosmos DB for drone scheduler service. And then the delivery service is using another type of database, which is the Azure Cache for Redis. And then when it comes to security, and authentication, it can be easily integrated with managed identity. Secrets are stored on Azure Key Vault through that. And then monitoring with Azure Monitor, and you can do your analytics through Azure Log Analytics Workspace. And in between, there's this communication, pub sub communication using the Azure Service Bus to handle the events. And sometimes we have this question as developers or cloud engineers: how can we build microservices based on best practices for cloud native, especially when it can be very complex? Because as the application or use case grows, I mean, based on my experience as well as a consultant working with different projects, an application can grow and grow and grow because the business wants us to add more features, add new things in it because the demand increase from the user side. But if you have a microservices, there's like, let's just say every month you need to add a new microservice in your architecture. Sometimes it can get too complex and each microservice is special and unique. So how can we handle that? So there's actually a feature in ACA or Azure Container App for Dapper. So what is Dapper? So I hope I pronounce it. It's just a shortcut actually, but I call it Dapper. So, but Dapper is an abbreviation of distributed application runtime, and it allows us in simple term without reading all the text here. You can read it yourself on the website. But what it does is that it improves how we allow or integrate the different APIs, or I mean the microservices that we have in our systems or application. And these are the common uh, based on the architecture information that I got from the official docs of Dapper. It has the option for state management. It supports the pub sub, output binding, secret management, input binding, and all those other features that is compatible or useful along with your workloads that are hosted on a container app. So, what are the APIs supported? So these are the ones that are common support for Azure Container Apps. So you have service to service invocation, state management, the pub sub, the bindings, observability and monitoring, configuration, take control of that, and also securely store your secret from your applications in those containers. So this is an example of a Dapper enabled container app. This is one of the examples that I will have on my demo as well. So here you see that it has this container app environment, like the box where you put the containers in. And it has two container apps, one that is a publisher, so because it's a pub sub, and then there's also a subscriber. And Dapper has the feature of sidecar. So you can have a sidecar for each of those container app that has its pub and the sub. And then it has the number of three part of it is your component. And it uses an Azure Service Bus for this communication. And it is just one example that is good to know. And there's actually more. I'll show a simple example one soon. But if you want to learn all of this, there are a lot, a lot to learn. First, you need to learn uh, Azure Container Apps. You do that through Microsoft Learn. Then you need to understand the basics of using Dapper, truly understand how it works. Then once you have that, then you can do both and integrate them together for a better result in terms of building a great microservices implementation in your projects. So there's a good learning path or documentation under this QR code, aka that ms/ACA dash Dapper, that gives you an overview about how it works with container apps and Dapper integration. So, and then I believe the third episode of this series, Stas has a special session focused on Dapper integration with container apps as well. So moving forward, so we did learn about ACA container apps. We learned about cloud native. We know that it's good for microservices and all these amazing features it has. Let's talk about Azure Developer CLI. So it's also known as ACD. So Azure Developer CLI is actually considered open source and developer centric tool, and it was actually released just last year, or maybe yeah, just it's very fresh. Before that was there's a Azure CLI as well, which is generally used for talking or communicating with Azure resources. But how does it work? Like, for example, you have a project, a simple web application project like this. So you have an app service that has this different staging or deployment slots, like for production, for state, for UAT, QA. You have your key vault and your networking. You have your database. you have your monitoring, and it's in a resource group. So this is a simple web application, but in a real case enterprise scenario application that are hosted in Azure, this is just so simple. The real ones are actually big and complex. And one of the things that that you usually have to do and deal with your team when you're starting a new project to the cloud is, of course, you need to do the planning. Of course, there's a business request from the business team. Hey, we need to do this project. Then you do the planning. You need to implement some kind of proof of concept. You have to do the team collaboration. You have to delegate your responsibility. You have to choose your technology stack. Are you going to use .NET, Java? What is our front end language, our framework? What kind of architecture are we going to use? Are we going to use containers? Or we're just going to do the traditional app service? And the tools that we need to use in terms of collaboration, coding, DevOps, and all those other stuff. And sometimes you also have to think about this. What kind of front end infrastructure is code? What cloud do you want to use? Do you want to do purely one cloud provider, or do you want to do multi cloud or hybrid cloud? Testing, how we would do it. Should we implement security in our DevOps pipelines? So these are a lot of things that you need to think about, especially in a bigger perspective and not just development. So as a developer, you're you're actually intended to just write code. That's what you want to do. But then the modern application project that we have today is actually very special because you have to learn and work with different tools and different things, and also work with different team members. So, source code, repositories, and projects, and different tools everywhere. And us developers, our productivity matters because if we feel that we don't have the flow or the focus in our mind, we lose our productivity. It's hard to solve problems. It's hard to build. It's hard to fix bugs on our code. And there are many distractions that we have in terms of tools to use here and there in terms of DevOps, coding, front end, back end. It actually affects the flow state in our brains that are intended to be smart and solve problems. So in my book, actually, I did presented the framework. This is a study that was conducted by Microsoft Research in terms of a developer productivity framework. I mean, developer productivity for space framework. And what it does, it identifies the several aspects in terms of uh, productivity. So in terms of the developer satisfaction, performance, activity, communication, and flow. And these things are actually important in terms of working and building applications to the cloud. And this comes to Azure Developer CLI, which allows us actually to build applications that are more developer centric, which means that we have this templates or CLI that allows us to build quickly in just few lines of code, and it also allows us to have this efficient and good workflow. So the typical Azure Developer CLI workflow is that you have your use case or project plan. Let's just say that you already decided what you're going to build, what technology stack, what language, and then you select the closest possible ACD template for it. So you select a template, you implement it in your own source code control repositories. You build your branches over it, depending on how many collaborators or developers working on it together. And then the next flow is that you do ACD init to initialize your ACD project. Uh, and then you can figure it out. You code your front end, back end infrastructure as code, which can be Bicep or Terraform if you want. And then your DevOps can be the Dev Container, Azure DevOps, or GitHub. And you do it on this important files in the ACD template. You customize it as you want, especially if you have a special type of use case. And then you just deploy it with the command ACD up once you are satisfied with that. And then you iterate your code changes and then you deploy it to Azure. And usually in a simple application, it can take very quick and it is easy to set up and it's quick. And why would you use Azure Developer CLI? It is actually developers centric for cloud development, meaning meaning it is focused on having everything in one place, like DevOps, the front end, and the back end. And this might be not ideal for all use case scenarios, but for example, if you have a good first project for modernization or a cloud migration, so it's good for proof of concept projects, or if you are a team that don't know where to start, but you have a project goal to do something in the cloud. So this is a good starter template or boiler blueprint template, you can call it. And all source code are shared in one workspace, which means it allows you and your team to work together. And even if you're coding different languages for front end and the back end, you can collaborate, and it's open source, it's polyglot, and it's very quick to get started, and it really helps with the productivity in terms of speed and delivery of what you need to do as a team or as a developer. So these are the definition of the CI ACD workflow: the init to initialize, the up to provision. If you want to iterate, you have changes, you deploy it. You don't need to push a button and do several steps. You just write in ACD deploy. You can do it several times from your local dev environment, and then it deploys to Azure with consideration, of course, that you have authenticated yourself already with your Azure credentials and subscription on the Visual Studio Code. So that's one of its authentication part. And then ACD provision, if you have this changes on your infrastructure that's beyond or not the same as the template, then you can re-provision your project for that. Monitoring is also supported. So if you do the command ACD monitor, it will allow you to, it will open up locally the App Insights metrics, and you can also do the live one, the logs, or the overview version of it. So ways to develop Azure Developer CLI. So you can do it locally. You can install it using the PowerShell, and there's a plugin on VS Code as well. Dev containers, you can do that with Azure Developer CLI and GitHub code spaces if you want to code on the go with code spaces. I did a blog about this on a community event last few months ago or last year. So I did blog about ACD in detail. So if you're curious about how to get started with it and how it works, you can check out my blog about it. So now it's time for demo. It's I have about 15 minutes, so I think it's just good enough. Let's see how much. Let me try to um, switch my screen. I have like three screens in front of me, so please bear with me if I toggle a lot. And I'm using dark mode. I have to apologize. I'm not using very light mode today because I tried it earlier. I got very sensitive to the super light in front of my screen. So I'm gonna keep my code into dark mode because I can see better with the good contrast. I'll just zoom in and then let me know if you're not able to see the code properly. And I will be giving you a link also to this example project, which is available on the ACD awesome templates. So just an introduction. So my plan for this demo is that what we're gonna do is that I'm gonna take a tour of the typical ACD template project after I chose the template, of course. And then I'm gonna try to show what it does on on this project, and then I'm gonna try to run it myself locally and then deploy it using ACD commands. So what it does is just like my presentation here on this demo, what it does, it is actually uh, an example of a microservice using PubSub or Azure Service Bus. It uses a topic. So there's, let's just say this is uh, a, a web shop that has a container that processes the order upon checkout, and it has the Dapper in between, and Azure Service Bus for the topic, and it has its subscribers, which the order processor. So that's the example architecture, very simple one. So what it does first, this is the format of the folder for ACD. So typically in an ACD template, when you do, let me see, let me just show you the template that I'm referring to. So if you do ACD template list, oh, no, it actually shows you. I have an ACD plugin, I mean extension already on my VS Code. But let's just say you and your team wants to look for some template to start with. So if you do the ACD template list, it shows you the different types of awesome ACD templates from for the community. Uh, and you can choose if you want a starter template for Bicep, for Terraform, or if you want an SAP integration, a React web app with Java. You can also have a template for like Azure Functions with Event Hub if you want to build something with ChatGPT using Java functions. So you have this different options, microservers services app with Java, and the example that we have is actually this one. So before the session, I did choose my template already, so I could prepare my code to show with you today. But if you want to build, for example, intelligent app, which is the theme of the series today, if you want to build a React toolkit for ChatGPT, you can also do that using ACD templates. Build from that template and improve it as you want. So there are a lot of options, like here, Azure Open API with Azure Boot. So it's building and building. So if you go to the AKMS Awesome ACD, you will get a lot of templates from both Azure community, from Microsoft, and even those contributors. So if you have a project built by ACD, you can actually submit your project and contribute for others to use as well. So it shows up here. So I just want to show you that how this command works and how you can use it. So I did select my template already, and that was the one um, with uh, with PubSub event for ECA. And in terms of structure, there is a structure for folder for .azure where you set up your environment. So while I was testing, I was doing a test run to create a demo environment for this one, but you can build as many environment as you want on the config.json. If you prefer to, like, for example, use dev containers, you can also configure that in your dev container.json. You got your Docker file here if you want to build that up on your configuration as well. And then if you want GitHub, you also have that option to build it in this folder. So there are special folders that I have here. So there's the checkout, the components, and also there's a folder for order processor, which are actually the the C sharp code that we have in here. So let's just say the checkout one. So when you do a checkout, let's just say in an order, I want to have, there's just like a basic loop of 550 for each loop that processes an order. So it kind of like it sends that message to the topic, the pub sub through Dapper, and it's gonna publish that. And then there's actually an order processor behind the scene. So what it does is that it's gonna process the order and the subscriber has received the data. And this is just like a simple example because it's just a demo. In a real order management system or web shop, this is more code. This is just a for each loop that tests the communication or integration in between the two containers. So that's those are the ones. And then when it comes to infrastructure, there are different parts of it. So infra, as ACD allows you by default, build infrastructure using Bicep here. But then you can also actually transition to Terraform if you need to. There's a guide how to do that. But by default, you get Bicep. And then on the core, you have this template ready for you. You can build with AI prepared already on this template. So I did not implement it yet because this is just an example. But if I want to build it up with OpenAI, the infrastructure is already prepared for me through this template. So which is awesome. I don't need to think about it. Even though every day in my project I code Terraform, but I understand infrastructure as code, I can just like use this template and build it up while learning the basics of Bicep infrastructure as code coding. So what I'm gonna do, since I'm almost out of time, I have 7 minutes. I have the timer, so let's see. I hope I have time for questions as well or follow up. What I'm gonna do is that I'm going to try to test run my application. So you have like a step on my README file here. And what I'm going to do is I'm going to do try to run it locally first. So I'm going to go first to my order processor. So to switch it, and then I'm going to do .NET Store. And then I'm going to do build it up just to refresh. Did. No errors. It's good. Usually demo doesn't work, right? So, and then, so what I did, just to explain those that are new to this as well, beginners, I try to be inclusive with those that are new in this technology. So what I'm trying to do is I have this project with checkout and order components. I mean, order processor, I mean. two containers, two backend services. And what I'm doing is that I'm gonna run those two backend services using the sidecar uh, feature of Docker locally. And what I have here is I actually have like Docker desktop running when I did the test on this one. So I'm doing that. And what I'm going to do is I'm going to run my Docker locally using my Docker containers. And it says that it is running, and the subscriber is uh, receiving this data of 20. And then what I'm going to do is I'm going to go to a new one, and I'm going to do the checkout this time. So I'm doing this in parallel. I'm not, maybe I can just do .NET build. Do I need to restore? Okay. Okay. So this one now is the checkout that I'm running side by side, or the sidecar part. So here, so what it did is that I did an order, a checkout, and now on the side, my subscriber is doing the ordering, and then my receiver has actually received this. It's like, the pub sub type. So, it's like running. I did a loop of only 50 just to test the logs. But that's how it works in terms of like testing or building locally. So I'm just going to stop it. Control C. So it had actually Docker containers locally. So let's just say I'm done developing it. I'm satisfied with my testing with the pub sub. I got the logs that I want with those 50 orders. I canceled it on 36. So what I can do now is I can do the deployment to Azure. So I already have the template, everything. So I just prepared the ACD up command, and it may take more or less 5 or 6 minutes to deploy it. And I'm also gonna try to show you what it is doing right now. I am showing my Azure subscription ID. Unfortunately, I cannot hide it. There's no Azure mask in Visual Studio Code yet. So you will see my subscription ID, but I think it's okay for now. So what it does, it's trying to provision Azure resources right now. I have 2 minutes. So it's trying to provision that. I'm just waiting. It may take a few minutes. So ACD, when you're doing ACD up, it's gonna like go through all this important stuff, like checking out the package that you have, and it's building, and then it creates this endpoint for your containers. So it generally did that, and it showed that my application was deployed to Azure. That was good. Probably I did the pre-work before. That was like quicker than I thought, but it did say it was done. So I will go ahead and go to my Azure portal, switch in between. And let's see, this is my Azure. By the way, today I got access to Azure Copilot, so I'm very happy about the preview, and I'm gonna try it actually when I have time one of these days. But this is my subscription for Azure, and I have a lot of them. And I believe I named mine. Let me see. I believe it's RG Dev uh, Jonah Test Run. Yes. So this was it. So this was the one. So with all the ACD app command that I did after testing locally, it went very quick, probably because I've been testing since yesterday. But what it did is that it deployed the checkout container app, the orders. It has the container apps environment, and then it has the registry as well, and it has the service bus that has a topic in it. So you did see the activities that it has. I tried to trigger it locally with all those, like you see the pick there. That was the 50, the for loop of 50 orders that I did earlier when I tested it. So that is my demo. I'm almost that I'm not almost time almost out, but I'm out of time. But I'm let me just show you a few slides here. And then I hope I have time for questions. So if you want to try this example, it's available. It's not secret to me. It's like I'm also a learner myself. So try it out if you want to learn. And there's a lot of things you can build on top of it, like the OpenAI feature and other services. And yes, just like Yoda, this is my favorite. You still have so much to learn, and I have more knowledge to share. I have a lot to learn myself, but feel free to go through a recommended learning path that I found that is useful, might be useful to you. There's a learning path in Microsoft Learn called Implement Azure Container, and then follow or read the container apps documentation and learn ACD because it's really a good tool, especially for getting started or proof of concept type of project, or if you want to implement it in your existing project as well. And there is a cloud skills challenge going on until the middle of April that I'm actually doing myself for building intelligent apps. So feel free to do this learning session or learning challenge with me if you want to develop your skills on these technologies. And in my book, I did write about these technologies that I'm talking about in a few of the chapters. Like on chapter 3, I wrote about Azure Container Apps as one of the PaaS or compute services, cloud native and automation, including infrastructure as code in CADA and Dapper. I also wrote about that in ACD in chapter 14. So feel free to check it out. If you want to read it, the preview of it, let me know. Connect on LinkedIn, and I would be glad to share it with you. So learn more in the coming sessions and have fun like my dog Lawrence. This was actually the rolling on the snow video that he did this morning when we did our walk on the snow. So we still have snow here up north in Sweden. So have fun, and I hope you enjoyed my session. Feel free to connect with me on LinkedIn, Twitter, or everywhere you find me. And I'm ready to take questions on the spot. Oh, there's a question. Great. Let's see. Let me see. Yes. Question. Let me see if I have time for questions. Where does the shopping cart si- entry reside while the order is being processed? Are you passing the cart data? Um, Okay, that question I think I missed that question during the demo. They are actually like the like two separate applications. So it actually uses Dupper. Let me go back to the the so it actually has the Dopper integration actually allows that to communicate to each other, and then the API endpoint as well. So you kind of have to call it using the endpoint that you have in processing those orders. I hope that answered that question. I think I only got one, I hope. And if missed any of your questions, please feel free to contact me anytime on LinkedIn. And if you have something that you think I should have added, feel free to reach out to me as well. I would like to learn from you. But thank you so much. I hope that you enjoyed my session. Glad to be here.